welcome to this channel, Fun of Physics, basically. So today, yeah, this pretty news channel, and I would like to tell something more shortly. I would like to teach something, and let's see what could we do possible. So, today I've been working on a mole concept, from chemistry. So I've thought, why don't I share what I'm doing? Because why not? Yeah, pretty much it. So basically, I'm a 11th grade student who's preparing for JEE right now. And let's see what could I do. And you see, my notes are too rubbish. I mean, too messed up. But yeah, let's see what could I do with this. Yeah, let's get back to this. So let's start with my day. Let me create a section. Yeah. Let's create a DPP day 33. I'm on day 30. I've got phases coming up in 4 days, which is pretty much, yeah, right? Phases, the mock test which come up in school in your regular, yeah, Fiera Foundation one. Okay, so basically, my first question is that calculate the amount of 90% extra support required for preparation of 420 kg. Okay, let's skip this. Let's go with something with start, which I probably don't know. Yeah. Cortisone is a molecular substance containing 21 atoms of carbon per molecule. The mass percentage of carbon in cortisone is 69.9%. Smaller mass is what? Yeah, let's see. So basically, you mean that there's some compound called cortisone. Yeah, cortisone, and it has 69.9% carbon. Yeah. So yeah, actually, but this compound contains 21 carbons initially. All right. The mass percentage of carbon in cortisone. Oh yeah, this is mass percentage by the way. Hmm. Its molar masses. Wow. Molar mass. Okay, remember what is its molar mass? So its mass percentage of carbon. So suppose it's assume the total mass of this compound is X. Okay. So 69% of this, 69.9 divided by 200 is 69% of this divided by 100 is mass of carbon, which is 21 into mass of each carbon atom is 2. So yeah, pretty much it. Let's and if I do this thing, we get around wait 21 into 2, that's 526 into 100. And the problem in this chapter is that this calculation itself it's too complex. So yeah, we get approx x is equals to 360.1. Yeah. So yeah, this is how we do our question. We look progress. Yeah, I appreciate myself. It's great. Now we get back to another question. Question number two. Yeah. So if you like the, should I upload the question into this? Yeah, maybe, but it's better to paste this question here. Let's go for something which is tough. So it would be better to explain rather than yeah. So let me copy this question. 1 mole of Fe reacts completely. Okay. yeah, this question's pretty tough because I found it tough. Why not? But yeah, let me grab this. And once it's not normal this, I don't know where the results come. So anyways, yeah, the question goes on like, yeah, one one mole of iron reacts completely with 0.65 mole of O2 to give a mixture of FeO and Fe2O3. The mole ratio of FeO and Fe2O3 is, this is pretty tough. Reacts completely, okay. Let's take, suppose the reaction is Fe reacts with O2. One reaction goes away, we get FeO2, FeO, yeah, FeO. And if we balance this properly, we get like 2 Fe and 2 FeO. This is, this is our first reaction. Let's go for the second one, which is pretty much similar, but we get Fe2O3. That's of course our baby rust. Yeah, FeO2 gives 2 Fe 2O3. Yeah, 2 Fe because you gotta balance that. Hmm. Now, this question is pretty brain cracking. You gotta think, because maybe I don't know. But in my first try, I never got this one. Like I had to take up some hint. So this question goes like this. Yeah, one mole of iron reacts completely with 0.1 mixture of FeO and Fe2O3. Mole ratio of, they asked mole ratio of ferrous oxide and ferric oxide, like mole ratio of these two. Okay. Now you might think that we can directly do, wait, this actually 4 F, sorry, my bad. Now we might think that, yeah, we got the moles, so 2 is 2, the answer is 1. But no, that's not. This is just theoretical mole. But like he mentioned one thing, like 0.6 mole of O2 to give this much. Okay, alright. So if you like, you know, from if you interpret from these two reactions, we can uh, write this in terms of variable as, like, yeah, x fe. Let's keep the quotients up. Let's write back this fe plus O2 gives fe O, right? And next one is fe plus O2 gives FeO3, Fe2O3. Now, like, yeah, as we interpret the quotients, like the stoichiometric quotients are gonna be like, see, if you see this, 2 moles is producing 2, and here if you see it's like if you assume this to be like 2, it's producing the same 2 moles and it's giving 2 by 2 moles of O2, right? So like if you assume that XFE produces same XFeO, then what would the like O2 O2 stoichiometric coefficient? It's of course going to be like x by 2, right? So x by 2. This is our variable form. Next, if we go back to the second, if you see the second reaction here, this is like, wait, let me write this clearly. Yeah. So if you assume that, like, see 4 moles is giving 2, and this is like, you know, by 4. Yeah. See, if if we assume this to be Y moles will produce Y by 2 moles of this, right? And Y by 2 moles of Fe2O3. Here we already have 3 oxygens, and we need Y by 2 into 3 oxygens on the left side. So you're gonna multiply this with Y3, Y by 4, right? You getting my point? Because like we are trying to balance this. So if you interpret, we get this from these two reactions. Now I want to let me clear this. Yeah. So Y3Y by 4. Yeah. And this goes on like Y moles of Fe gives Y by 2 moles of this. And if this Y by 2 is given, and there are 3 oxygens already, so we gotta balance this. They're like Y by 2 plus 3Y, 3. So we gotta balance this on the left side, so I multiply with, like we have like 3Y by 2 moles on the right, like oxygen moles. And on the left we got 3, like we got 1 initially, so we have to multiply this with 3Y by 4 so that we balance this as per law of conservation of mass. We don't forget that. So yeah, this is our main thing which we have to proceed with. Now this in this variable form, this has become much more easier, right? Don't you think so? Yeah, like even if you can't like figure it out right now too, let me get further. So uh this one where we are at, hold on. Yeah, the more of this and this is, yeah, there's a more ratio. If you get back to the question, there's a more ratio. And we took 0.65 moles of this. So we just have to, like basically we got to like see, that we are taking like 0.6 moles of O2. Like basically combined O2 is X by 2 plus 3Y by 4 is, if we compare with above reactions, both the coefficients are 1. Yeah, 1. Sorry, no 1. I mean 0.65, yeah. 0.65. And next, if we go for this like other one where we get like x plus y is, yeah. Now let's see. Now let's like simplify this one. We get 2x plus 3y is equal to 0.65 into 4. So 0.65 into 4 gives 2.6, which is like 2.6, right? No, yeah, 2.6. 2.6. And if we divide this by, yeah. And in the question, if we get back to this, 1 mole of iron, again, 1 mole of iron reacts with 0.65 moles. So if we interpret like x plus y is how much? 1. Because like yeah, the question meant that like 1 mole of this. So that's how crucial it's to like study the question back again. So yeah, now we got another equation which is x plus y is 1. If we solve for these two equations, we get like into 2 minus, then we get y is equal to 0.6, and x we get like 0.4. And if we divide these two, like they ask us to find out the ratio of FeO and Fe2O3, which is producing like 0.6 by 2, which is y. Basically they're asking us x by y by 2. That's like the more ratio, right? As we interpreted from these equations. So that is 2 into x by y, which is 0.4 upon 0.6. So yeah, this is going to be 0.3. We get 4 is to 3. The ratio is 4 is to 3. And that's a final answer. It's pretty good question. Yeah, so this is a good one. Now this is our like first step. Now let's go to another question, which I'll get pretty good ones. Let me get another. Yeah, let's go for this. So yeah, guys, let's have some music in the background. Then it's gonna be like, let me increase my volume over it, and let's have a little music. So I don't know if you can hear this. Mm, yeah, that's how we do little chemistry. This is a good question. Let me get another question, guys. Oh, which is like, yeah, this is another good question, which I would like to try again. An equimolar mixture mixture of COOH, hold on, OH, yeah. Yeah, let me just play it business. It's gonna be really good. Oh damn man, that's so huge. Anyways, doesn't matter. So yeah, let's see. What is this question telling and what could we interpret? Dun, dun. Oh man, such a good part of this song. An equimolar of COOH. Oh, equimolar mixture of COOH2 and HCO weighing 100 grams is treated with concentrated H2SO4. The gases evolved are passed through 1 liter of lime water. Yeah, 1 liter of lime water containing 1 mole of CaO3 in twice. How could the weight of CaCO3 form? Chemical equations involved are okay. So let's get to a solution. Like if you would like to try this. Give it a shot. Pause the video, and yeah, you can. Now, let me start this. The equivalent of this and this, yeah, like COOH taken twice and HCOOH weighing 100 grams is treated with concentrated H2SO4. Like let's take mm, COOH. Yeah, this is another my favorite song. Yeah, it's taken twice and plus HC COOH weighing 100 grams. Like, let's assume the mass of COOH to be A. So this is gonna be 100 minus A. That's of course, like the question tells that thing. Of course it does. 100 grams is treated with concentrated concentrated. This is treated with, a concentrated COOH, like HCO, H2SO4. It's like Kings of Acid or something. I don't remember. When I was like at seventh grade, my chemistry teacher used to tell that, yeah, sulfuric acid is like the king of the acids, the best one. No, come on, it's to SO4. too much to consider. Yeah. The gases all passed through 1 liter of lime water containing this. So yeah, this reaction, if you remember a great term, which is like when we pass CO2 to lime water, then we get this music still loud. Let me just record it. Hello. Hello. So when we pass CO2 to like lime water, like calcium carbonate is deposited. The way I remember calcium carbonate is super funny, which is like I used to call Kako 3. Yeah, it's Kako 3. Calculate the weight of Kako 3 formed. Chemical equations involved are okay. Okay. Oh, oh, oh. No, not this. Blah, blah, blah. Let's see what it is. See, assumptions one. Like, yeah. Or maybe, like, let me now assume like mass to be A. Let me just assume that the equimolar, right? Let's assume this to be A moles, and I assume this to be also an A moles. Okay. Now we go back to the question. Equal mixture of this and this. Where is this? So, like, it's treated with concentration H for the gas all liter of lime water containing 1 mole of CaOH taken twice. Calculate the weight of CaCl3 formed. Calculate. Okay. Now let's see how many moles are reacting. Now this is pretty easy to calculate. I mean not very easy. We know that. Let's get back to the basic. We know that number of moles is equals to given mass. I mean, sorry, given mass upon molecular mass, right? This is like now visible, right? Number of moles is given mass upon molecular mass. Yeah, like the molecular weight. Well, molecular weight. Yeah. So we can get like mass of this is number of moles into molecular weight, right? So number of moles of CaO taken H taken twice is A into molecular mass of this, like mass of I'm just trying to like add this because in the question he mentioned that the equivalent mixture both weigh 100 grams together. So like mass of COOH taken twice plus HCOH both weigh 100. So like each mass like moles into molecular mass of this is 96. I suppose 90. I mean 90 plus A into this is gonna be 90 plus 1, yeah, 91. Okay, hold on. So, yeah, this is gonna be 40, 41, 46. Yeah. Like 12 plus 32. 12, 12, 12 plus 32 plus 1. Yeah, 45 plus 1. So 46. So, yeah, this weight is 46. Okay. This like combined mass of this first one COH taken twice plus HCOH is 100 grams, as we know that, right? 100 grams. So we can get A from here, which is like 6 136 100. A is 136. 100 divided by 136, right? So yeah, A divided by 100 divided by 136. This is moles of the first one and this one. Next, treated. Now let's get back to the question. Treated with concentrated, the gas evolved are passed through. So if you write individual reactions of this, like COOH taken twice plus H2SO4 produces some amount of like CO2, which is like let's see CO2 and yeah CO2 plus H2O CO2 plus H2SO4 no CO2 plus well let me get this reaction COOH taken twice. So guys, sorry if I'm like lagging a little because yeah, of course the oxalic acid reacting with H2SO4 gives SO2 plus CO2 plus H2O. See, this gives 2 moles of CO2 plus some like external things. We don't really, that doesn't really matter. And other one is HCOH, HCOOH plus H2SO4 again. This gives, oh yeah, let's say CO2. Plus, yeah, that's it. Now, wait, let me just cross check this reaction. HCOOH plus H2SO4. This produces carbon monoxide. No way. Yeah, the gas all are passed through. The gases evolve. So like this doesn't produce CO2. This produces like CO, carbon monoxide. So like carbon monoxide doesn't react with calcium carbonate. So we can eliminate this reaction. The complete precipitate which is formed by in this like reaction, in this the Kakotu which is formed in the final reaction of like passing the gas towards like 1 liter of lime water is all due to this reaction, which is COOH. Like it's taking the whole burner because it's the only thing which can produce carbon dioxide. Got it, guys? Yeah. So now the gases evolve plants through 1 liter of lime water containing 1 mole. Yo, it's taking charge. Calculate the weight of. Hmm. Now let's see how many moles of this are. So see, initially 1 mole is producing 2 moles of CO2. Now let me just quickly erase this reaction because it's already useless for the question. So 1 mole of COH taken twice is producing 2 moles of CO2. So A moles will produce 2A, which is A we have just right now calculated that it's 100 by 136, 2 into 100 upon 136. Yeah. That's gonna be 2, 6, 8. Yeah. So basically, that's like 100 upon 100 upon 68 moles of this is reacting with. Yeah. So like the CO2 gas which is produced, like the amount of CO2 which we have is 100 upon 628 668. So they asked us to calculate uh now like if we write down the equation for this CO2 plus, oh let me take the white color, plus being racist, but yeah, we're right. CO2 plus CaOH taken twice gives gives us CaCO3 copper 3 plus H2O, I suppose. Yeah, H2O. So one mole of this, right? They mentioned this. Pass to one mole of this. Calculate the weight of CaCO3 from the chemical equation. See, one mole, like let's see which is the limiting reagent. So this is 100 upon, let me just quick calculate that. 100 upon 68 is 1.4. 1.4 of CO2 and one mole of this. So the limiting reagent over here is gonna be Ca CaOH taken twice. So reaction goes according to this because here it's completely consumed. So one mole of this is producing 100 grams. Hold on, give me a second. Hold on. He gave us a reaction there itself. So yeah, CO2 is gone anyways. That's like the previous which we have already interpreted. Next we get CO2 my bad. So yeah, back to this 1.4. Let's balance this. Sorry, I forgot to balance that. It's already balanced, I suppose. Let's do yeah. Almost. Asia one more. So it's now why is this taking too long? Don't ask me please. Just actually make it long. Oh, 30, 30, 30, 30. And we get 5.5 grams. So yeah, most of central food. That's what I really did, man. Hold on, 100 upon 68. So 1.4, but why not? Why is this thing before doing it? Okay, hold on. Let me just do this question properly. Unequal amount. So yeah, guys. Also, by the way, like I've written this section very wrong. So shit, sorry guys, forgive me. The moles produced here are 100 upon 136 itself. So A is 100 upon 136 only. So yeah. So we get like here the moles of this is 100 upon 136, which is of course less than 1. So the limiting reagent is CO2 So the reaction goes according to the CO2 because it's gonna get completely consumed in the reaction. So 100, like 1 mole is producing 100 grams. So of course 100 by 136 will give 100 by 136 into 100. Yeah. So that's gonna be, if we calculate that carefully, 136, which we are gonna get 0.73 into 100, which is like 73.5 grams. Yeah. So that's the yield, which we are gonna get 73.5 kcal 3. Brilliant, brilliant. That's pretty good questions. So yeah, thank you guys. I know I've lagged this like too much. So when I thought like, let me just you know finish this up to here and let's have fun. I'll meet you guys in another video. See you until then. Bye.